Let's get started. Welcome to Purdue Orbital's Callout for fall of 25. I'm the president for this year, Max Lopez. I'm very excited to have all of you here. We have a lot of cool things planned for the year, a lot of cool things to work on. So let's start talking about them. So let's go over our mission statement. So it's to foster technical and professional skills of all our members by designing, building, testing, innovative solutions to complex problems in the aerospace industry. Now that's a mouthful, I know, but we have very intense goals, but that's not to scare all of you because we can accomplish all of these goals with passionate and driven people joining our clubs, collaborating together, working on stuff. This is fun to us. This is supposed to be fun to you guys. So with your help, with you guys joining, let's work towards these goals. Let's make cool stuff happen. So don't be intimidated. I know hearing a lot, we make rockets. We do a lot of cool stuff with balloons. Like you might not know anything about that. The reality is a lot of us didn't know anything about any of these things upon joining. But don't worry, we have people to mentor you. We have people to teach you. You're going to get out as much as you put in. So if you're there, you're ready, you want to learn, you're going to learn a lot, probably more than you want to know. So it just, be open to it, enjoy it, have fun. And the big thing with us is that, and what sets us apart and what I take pride in is that not only do we just make cool stuff, like we invest in you guys. Like we want you to have a good time. We want you to have skill sets you can apply not only to us, but to industry. We're recognized a lot in the field. Like a lot of people see, oh, you're an orbital. That's cool. Like we want to give you a job. That's what's happened to a lot of us. So just, keep that in mind. Like we want to give you skills that you're going to be able to use later on in life. So just a little bit about, I guess, the logistics of this club. We have currently 150 plus members. We span all different types of just school units, just different, all types of majors. Don't feel like you have to be in engineering. We have a spot for you on this club if you really want to join. Since our founding in 2015, we've raised over $300,000 in funding. And when we first started, we started out as a startup simulation program. And the year after, 2016, we had our first high altitude rocket launch. 2017 was our first balloon launch. Since then, we've done a lot. We've had over 25 successful test flights, and we've reached maximum altitudes of over 40,000 feet. So a lot of cool stuff. We have way cooler stuff planned for this year. I'm very excited. So hopefully you guys join and try and join and apply. So now I'm gonna hand it over to our chief HAPS engineer.
Thank you, Max. All right, can I have my HAPS DL come in close? Thank you, guys. All right, my name is Danielle Evinger. I apologize that I have lost my voice, but I am the chief HAPS engineer. And also a special hello to all the girls in the audience. It's great to see you guys from the call out. All right, the HAPS program, what are we up to? The HAPS program is launching a rocket from a high altitude weather balloon. The HAPS program unites these multidisciplinary teams to take on a systems engineering challenge of launching this rocket from the balloon, pushing our student innovation higher, faster, and further. Why raccoons? This seems like a crazy idea, and here's why we're doing it. There is a higher performance potential. So launching a rocket above the atmosphere can reduce drag and fuel waste, letting us use smaller rockets to reach near space. Secondly, you're going to gain hands-on aerospace systems engineering training, really simulating a commercial environment here. Thirdly, our innovation potential is huge. This is not widely used in industry, and so we have a lot of potential to create new systems and think of really unique ways for our launch, our stabilization, and our staging for this rocket balloon system. So this year, if you were to join Orbital on the HAPS team, you will be seeing several high altitude balloon launches. One of our first will excitingly have a GNC payload on it, which will be awesome. You'll hear from Brad later about that. And then also a student payload. We're working with the EAPS department to get something going. And then also some full up systems tests. So one should be here at Purdue for any HAPS member to view and attend, which would be awesome. And then also a huge launch, full scale launch of our HAPS system with a rocket at Friends of Amateur Rocketry, similar to a test that we did in the spring of 2024. So a lot of exciting things going on in the HAPS program, a lot of systems engineering, interfacing, and making sure that all these teams are working together effectively. So I'm going to pass it off to our design leads to talk more about their specific subsystems.
All right. Hello, everyone. My name's Danush. I am the design lead for airframe. So airframe is one half of the picture of rocket balloon launches. It's the rockets, which you guys see up there. So the one that I'm going to talk about on this slide is Novo. These are the rockets that we're going to be putting on the balloons themselves. So we've had a history of being able to launch these off the ground. So a lot of our work this year will be moving forward with designs to get these launched off the balloon system itself. So obviously launching on the ground is more straightforward than it is launching 2,000, 20,000 feet in the air. So there'll be a lot of good design opportunities available to everyone. So even if you're a freshman and you don't know a lot, we have a lot of good onboarding experience to make sure you understand everything. And a lot of the engineers that you'll be working with will help you make sure you understand. And you'll have a lot of individual contributions you can apply to this project. In terms of hard skills you'll learn, you'll get to work with CAD, FEA, different proprietary simulation software, as well as some soft skills like inter-team collaboration and multidisciplinary collaboration. I'm assuming all of you guys want jobs one day. That's one of the biggest things that every company is looking for. So there'll be a great spot for you guys to get those skills and work with a bunch of different teams.
Hey everybody, my name is Jack Herman. I am the launch structure DL. So what actually is the launch structure? Basically, it's a carbon fiber frame that is responsible for housing a lot of other systems. We're the team responsible for ensuring that the rocket and all its components get up to the launch altitude safely. So what you get to experience in launch structure this semester is we're working on 3 things right now. One of those is a complete redesign of a system called TUG, which basically on the day of launch is responsible for releasing the launch structure. So a lot of CAD skills there for those interested. Even if you know nothing about CAD at all, great chance to learn. We're also working on a redesign of our electronics housing unit. So for those of you interested in geometry and math and like optimization problems, stuff like that, come to us. And we're also the team responsible for capturing footage of flights on test days. We work with GoPros and drones. So yeah, I hope you guys join launch structure. Thank you.
Hey all, my name is Josh Beverung. I'm the design lead for the flight operations. Flight operations is essentially responsible for making sure HAPSIS and the balloon gets up and then also gets back down. So our goal is to answer 3 questions. First one is how do we actually control and make sure the balloon can get onto its initial ascent? One of them is what does our ascent actually look like? How do we model it? And then how do we get the balloon and the launch structure down? So throughout this semester, we're going to be working on these 3 things. We're going to be first working on a new reliable deflation mechanism for our system. This is brand new. So if you're interested in any CAD design, any modeling, we're also going to be like prototyping and testing it this semester. That is another reason to join flight operations. We're also going to be working on a small electronics system to help communicate with our tech up on the neck of the balloon while it's up in the air. This is going to help us make sure we can do smaller tests in a quicker way. And then we're also going to be working on physics simulations for this ascent. No experience required for this. The physics simulations is very new. So anyone aspiring to go into that physics kind of area, come to flight operations.
Oh, sorry. Hi, I'm Bradley Gronick, and I'm the Guidance Navigation and Control Design Lead, also known as GNC. Now is the perfect time to join because we're working on some really cool things. What you'll see is at the top left, that's a prototype we had at the end of last year of a cold gas spin stabilization system. What that means is that we have a compressed air tank on board connected to solenoid valves and nozzles, which will help not only prevent the HAPSIS launch structure from rotating during ascent, but also make sure we can point it so we know where the rocket is launching. Because not only do we want to know where that rocket's going to go, the FAA also wants to know where that rocket's going to go. So it's a great thing to have on board. And that's the prototype we had in the fall of last year. The bottom right is our system on the HAPSIS launch structure in a test. So if you can play that video, you'll see in that video, you'll see Wes, our Icarus chief engineer, giving that launch structure a spin and then it pointing itself back. Pretty crazy, I know. But that's just the start. Don't worry, there are plenty more tests you can join in for this fall so that we make sure we have a flight-ready system for when it launches at the end of this fall and maybe again at the end of the spring. So if you want hands-on experience with that testing and that optimization of our system heading into the spring, I would highly recommend you join GNC.
Hello, everyone. My name is Alex Schaefer, and I am the DL for avionics here at Purdue Orbital. Before I tell you what we're about, so one important thing is we're actually not just HAPSIS. We're part of another project called Icarus, which you'll learn more about later. Now, what do we do as a team? Our team is normally split into two different halves, hardware and software, which if you need more information, we'll have our DL or more REs over here. So, more specifically, there's a lot of skills you can use in avionics. As you can see, we have a giant list here, such as KiCad for PCB design. We have things like CAN bus for transcommunication across boards. Now, if you don't know what any of these things are, quite honestly, I didn't either. So within a month of joining this club, I learned all of these things I need to know, and I'm here where I am now. So don't worry if you don't know anything, we'll get you where you need to be.
Good job, HAPSIS.
All right, Icarus, if you can head up here, that'd be awesome. So before we get started, I just want to say a huge thank you for everybody coming out today. It means a lot that you guys can come and hear about what we're so passionate about. We all decided to be on leadership for this club because we believe in its vision and we know that we can achieve these goals, and we hope that you can join our mission. So without further ado, my name is Wes Crone. I'm the chief engineer for the Icarus program, and I'd love to introduce you to it. So what is the Icarus program? So the mission statement for the Icarus program is to empower college students to develop student research and develop systems to get to the Kármán line. What is the Kármán line? It is a line 100 kilometers above the Earth's surface that is generally accepted as space. So what I'm really saying is we're going to space, which is really exciting. And as aerospace nerds, I'm sure everybody in the audience is super excited to hear that. So now, what are our objectives? How do we get to where we're going? First, this semester, we want to conduct 2 launches with an SRAD solid rocket motor. We want to conduct further research and design. I know we do a lot of research and development for rocket structures. We're at high speeds. How do we get that rocket to survive? We want to upgrade our current payload launch platform so we can continue to launch these student payloads to do science missions and other really cool and exciting outreach opportunities. We also want to conduct the first flight of an SRAD GNC system on a rocket. What you saw in the past was a launch structure. We want to put a GNC system on a rocket and fly it. Lastly, we want to conduct propellant characterization, which is something under propulsion, which you'll hear a lot more about, with Sucro Labs on our propellant that we have developed internally in-house. So I hope that you're all so excited to learn a little bit more about the design leads for the Icarus program. Without further ado, I'll pass it off to them. So first we have GNC.
Guess what? I'm back. Still Bradley Gronick, still the design lead for guidance, navigation, control. And we're not a one-trick pony, we're a two-trick pony. We have another cold gas system that, while similar to the HAPSIS system, has a full different set of constraints going on a rocket opposed to a launch structure. And if you were thinking, well, testing is cool and all, but I want to design a system, that is something you can do with GNC, because on Icarus, we are not only building and manufacturing this system. You see the CAD model up there? That's because we don't have the physical model. We are ordering the parts this semester, and you can join in time to help assemble that system and get it on a rocket. But you might also be looking at that bottom right picture and thinking, well, that doesn't look like a cold gas system. If you're particularly astute, you might recognize it as a reaction control wheel. And that's because we are looking at so much more than cold gas systems. This is a perfect semester to join in and see what GNC will be doing next and have not only learn about these systems, but give your input and join from the beginning on a whole new project. So if you want experience with any of that, from building the system to testing it, or before you even build it, designing the system, join GNC.
Hello, everyone. I am back again because turns out we do more than just one rocket. So once again, for those of you who might wanted to remember, my name is Manoush. I'm still the airframe DL. And what we do on the Icarus side are these 2 rockets we call Theseus and Stratos. So Theseus is, this is one of the parts of Theseus. So you'll notice this doesn't look like a full rocket. That thing looks like a full rocket. That's because Theseus is a fully modular rocket. So our current design of it is all aluminum. And if you guys were like, oh, that looks already kind of built, we're going to be transitioning it into a fully fiberglass design. So there's still going to be a lot of great design work to do there. Theseus is historically our rocket that we use for a lot of our payload testing and other R&D applications. So if you're looking for more of those multidisciplinary integration skills and working on a lot more of niche design problems, Theseus would be a great project to work on within airframe. And if you're looking for more flashy numbers, if you guys recognize that 40,000 feet number we hit, that would be that Stratos rocket right there. It kind of looks like it's not going too high, that's because it hasn't yet. But this thing goes very, very fast. It went a speed of Mach 2.7. So I don't know how fast you guys can run, but I never know I can run that fast. So that one, we focus more on design for high-powered rockets. So these are the types of iterative designs and steps we take within airframe to help with not only grounded launches, but also the launches we'll do with like similar to Nova off the HAPSIS balloon. So once again, it'll be this very similar skill set that you guys will learn from either on this side or on the Icarus side. You'll have the opportunity to work on whichever types of rockets you guys are interested in. So thank you.
Hey, what's up? My name's Tucker and I'm the prop DL. If you don't know what propulsion means, don't apply propulsion. No, I'm playing. But in all seriousness, we have 3 big projects this year. First, we're building a test bed. So it's basically just a big hunk of steel that allows us to put motors in it that we make in-house and then test them and like be able to understand the characteristics, get actual values from it and all that jazz. That's pretty cool. So to have one of those to be able to work and fire continuously is pretty awesome. Second, we're trying to build up our mixing and casting capabilities. In like the bottom left picture there, that's us mixing and casting. It's slightly grimy, but you know, it's a lot of explosive stuff we get to work with. We would do that over in 2 grow labs. So that's like, it's actually the world's largest propulsion lab. So it's pretty cool to like actually do stuff there. So that's mixing and casting. We're hoping to be able to just build, like create more motors at one time. So that gives us a lot of opportunities to really design new parts and actually go through real life motor assembly and design. This is real energetics. We're actually casting, we're actually firing these, which is pretty cool. Lastly, we're trying to make a 48-inch motor this year. We launched a 24-inch last year, so we're trying to double that by the end of this year. 40 inches is pretty big, at least by my standards. But we're trying to get that on a high performance rocket, and that'd be pretty cool because that'd be a rocket we'd actually build, fly, start to finish on our team. We're going to show you the hot fire bottom right here. This was last semester, and it's pretty dope. Still quiet. I don't know why it's quiet.
It's a lot louder.
That actually shook the building. And if you are there at the building when we launched that, like it like rumbles the building. That thing's producing hundreds of pounds of thrust, and like that thing moved a 250-pound like barrier 6 feet away and on the floor. So like that's a real thing. And that motor also went Mach 1.1 in the rocket you see in the top right. So this year we're looking to do a lot more projects. We have structures, thermals, mixing, casting, a bunch of different groups. If you're interested, I'm Tucker, propulsion. Thanks, guys.
And the only way you hear what a rocket sounds like if you join the team. So you have to join.
Got it.
All right, now we'll hand it off to our systems engineering program.
All right. All right, thanks for sticking around this long. We are the systems engineering program. My name is Luke Hunter. I'm the chief systems engineer. So a little bit about what we do. How many people in here think what we've talked about so far looks super easy? Yeah, looks about right. It's not. It's incredibly difficult, and it takes a lot of moving parts and a lot of people to come together. And because of that, we work to ensure that no one's movements are wasted. We make sure that, the needs of the stakeholders are turned into actual items for the teams, aka requirements. And we ensure that the interfaces between those teams are built to succeed and not be wasted, and make sure that no one's time in this club is wasted. Additionally, because of that, we get to learn pretty much every aspect of the club. We get to have a comprehensive understanding of every part of every mission so that we can help move it forward. We also get to guide the direction of design and ensure that the quality of our final product, for everyone who dumps a lot of money into this club. As you can tell, $300,000 is not little. So we also work to ensure that these tests are done safely. As you've heard from all the teams, a lot of things that we do are dangerous, and we make sure that at least most of our members leave with all of their fingers. Additionally, we operate pretty much as close to industry as you can. This is a huge part of actual industry. Anyone who has worked in industry is able to tell you that. And in order to talk a little bit more about the specifics of what we do, I'm going to hand you over to our DLs of the HAPSIS and Icarus sides of systems.
Hello, everybody. My name is Marty. I am the design lead for the Icarus side of the club. All these teams, they've been talking about integration, testing, collaboration, all this stuff, but we are the ones who actually make sure that happens smoothly. And we do this in a few ways. First of all, we have to make sure all the parts of each of the systems work. And to do this, we give each team guidelines that they work off of. And then once they make their projects, we review project plans, which are basically just overviews of each project, which anybody can access in order to understand what's going on in the club. We also facilitate design reviews, which are basically just moments where teams take some time, pause, talk to each other, make sure everyone's doing what they're supposed to, so integration goes smoothly. And to verify that the assembly is cohesive, which is just a long sentence for make sure smooth integration happens, we take some time, talk to each of the teams, make sure everyone who needs to sit together gets to sit together and has a meeting and talks about who needs to do what, right? And we also create testing procedures, which is super important in order to maintain the safety in our club. These are something that you'll do in industry as well very often. And we also review interfacing with teams, which is a little step down from design reviews, but also very important because design reviews don't happen very often, but this does in order to make sure everyone works smoothly together.
Hi all, I'm Ryan. I'm the Hassett Systems DL. And the last thing that Systems is really hitting on the head of the nail is to keep everyone informed. We want to make sure that all our documentation is up to date and that everyone who needs to look at it has access to it. We want to make sure that those project plans can be reviewed by leadership and that any problem spots can get some little extra attention. We want to make sure those standard operating procedures are in place to keep everybody safe and make sure that launch days proceed as planned. And we also want to support all of our teams in both communicating their ideas and goals. And then we want to congratulate them when they successfully accomplish their missions.
Awesome. Now we're going to hand it over to our brand new mission design team here.
Hey, everybody. Doing all right. My name's Trey. I was previous president last year, and this year I'm starting a new and unique opportunity called the Mission Design Team. So this team is really focused on advanced astrodynamics concepts. If any of you guys know about anything to do with spacecraft navigation or orbit design or anything related to that, if you're an advanced upperclassman or a graduate student, perhaps, I'm starting a new team to really focus on those skills and give you guys some hands-on opportunities. So in particular, if you have taken a 340 or a 364, I'm going to suggest that that's kind of the level you need to be at in this team. We're going to be exploring some analytical methods and some commercial tools, and we're also going to be bringing in some PhD students to talk about their research and their work and also explain some of these advanced concepts to us. So this semester, we're going to be starting a new lunar mission design to NASA's Gateway, and we're going to be doing all of the orbital mechanics and spacecraft navigation required for that, including some three-body problem dynamics. So that sounds interesting to you and you've taken some of that coursework, feel free to join my team and come talk to me after this. Thanks.
One of the other interfaces that Systems is able to work with is between the technical design teams and the manufacturing teams. Unfortunately, our chief engineer of manufacturing is away on co-op this semester. So, it shows that we do have a lot of industry connections and you're able to get, a job out of this. But to talk about the manufacturing program is Max.
Cool. So by now you've heard we do a lot of cool stuff, and we build a lot of cool stuff, but we need, how do we make that? That's where manufacturing comes in. We have a lot of cool people and a lot of machines to do so. So if you join manufacturing, you're going to be learning how to use CNC machining, CAM programming, welding, 3D printing. You're going to be working out of Bechtel Innovation Design Center, which is a privately funded facility that has huge machines. It's 3 stories. It has all state-of-the-art CNC and mills to use at our disposal. So that's pretty cool. And manufacturing really is like a backbone for us. They're the ones that are going to work and model machine parts for all of our systems. And I guess your big takeaway from it is going to be, you're going to be learning how to design for manufacturing assembly. An industry that's going to be your biggest thing, how to be efficient with your time and not waste resources. So upcoming technical objectives for manufacturing, obviously you're going to be supporting every rocket that's being produced. You're going to be supporting all our launch structures, all our ballooning infrastructure and architecture, as well as the creation of our GNC flight weight model, which you have heard about by now. So you're going to pretty much have your toes in every project going forward if you join manufacturing. So now I'm going to hand it over to our enterprise and operations team.
Hi, everyone. I'm RJ. I'm the treasurer for Purdue Orbital. And what the treasury team does is essentially we budget the club's funds yearly,
And then the most important thing about being a club is we have to have money to be able to do all the fun things we want to do. And the easiest way to do that is applying to grants through Purdue and Exterior Motives. And this year alone, Purdue has given us nearly $50,000 in grants to operate as a club, which is extremely exciting. And then together with our operations team led by Rachel, I work to build fundraising from corporate sponsorships is the main way to do it. And that just helps build relations with different corporate entities amongst our teams. And now I'll hand it off to Rachel.
All right, my name is Rachel. I'm the operations director here at Purdue Orbital. That means I'm head of outreach. That encompasses our identity, media, and initiative of the team. The most obvious thing that we do is social media. We do a lot of cool things at Purdue Orbital, like a lot. And I don't want any of it to fly under the radar. So it's really important that we can document these things and post them and share them so we can put our best foot forward. This includes like the Instagram, the LinkedIn, so people can repost it and look cool like to businesses on there, our YouTube, and also running the website. We also have outreach initiatives like this one, or when we're tabling at an event and we have to coordinate those, set those up, and make sure everything runs smoothly. Buy you guys a bunch of pizza, which you're almost about to get. This is the last thing. And then we also do fundraising and sponsorship with the Treasury Department. I really like this part of it. I get to talk to a lot of businesses and really network with them, which is really exciting for me. I love talking to people. And I get to form a lot of personal relationships with them, which is really cool if it's something you're interested in. And this also leads into our events. We do a lot of social ones like this, but also we do corporate events. So last year we had an event with Blue Origin. We've had events with SpaceX in the past. We toured the Aerospace Corporation when we took our trip out to the Mojave Desert for FAR. So yeah, if you're interested, if you like Canva, if you like Instagram or social media, definitely come talk to me afterwards.
Cool. And now to answer the question that I'm sure a lot of you have, what are the next steps? How to apply? So you can do it in one of two ways. You can either look up this website, you can scan this QR code, you can scan it now and just save it for later. We're also going to publish these slides. They're already uploaded to our website to look back on. So yeah, go ahead and do that. After that, you just hit join the team. Under that, you'll have a here link on where to find the application, and then go ahead and fill it out. We're really going to stress that please like take your time, fill it out, be thorough. We want to get to know you. Yeah, like just actually try it on the application. We want to like know who you are. Because if you just are like, hi, I'm whoever, cool. Like, what are you interested in? Like, yeah, please let us know. So yeah, teams we're currently looking to grow. A lot of them. We have them listed here: avionics, airframe, flight ops, outreach, and treasury. So if you have an interest in any of those, please do apply. Any of the rest also do apply. But thank you. Yeah, thank you for coming out. Thank you for letting us take your time. If you have any questions, we're going to be up here to answer them and have some free pizza.